Hi there, welcome back. I want to finish the analysis of this audio circuit. I'd got as far as following the signal from the pickup input over here, all the way through with mono selected. And we saw that it went through here. This triode fed that pentode, the output. And then this signal was inverted here to drive that one with an equal and opposite signal. Now, I wasn't quite sure how this section here worked. I know that the signal comes in here, gets in there, gets inverted, there's some feedback, and I thought this whole mystery of how this thing would balance was very complicated. In fact, it's not as complicated as all that, because somebody correctly pointed out that this thing is called a seesaw phase inverter. Now, it's not a typical seesaw phase inverter. I've only come across it once, and it was in a theoretical situation, so didn't remember it at all, so thank you very much for reminding me. And I read up the article that this viewer linked for me, and it makes sense. It is different, and it's different because the typical seesaw phase inverter has 1, 2, 3 resistors that are usually the same value. They actually mention 1 meg. Now what happens then is you've got the signal here, call it signal A, it goes through there, and at this point you'd have half A. Why? Because if that's 1 meg and that's 1 meg, and at audio frequencies this thing is practically a short circuit, this is a potential divider that divides the signal in half. Then what happens is this signal gets amplified and inverted, and here you have the inverted version of that half A, but amplified. Amplified and then connected back through another 1 meg resistor. This would typically be the same value as those two. And this means that when the signal goes up, that one goes up inverted. So it basically makes the balance between A and an inverted version, an amplified version of that, meet in the middle, and whatever is predominant will make that signal go up or down. So this thing sort of reaches a balance in almost a seesaw fashion. These are the two versions or the two parts of the seesaw, where if this signal goes up, forces that one to come down because it's inverted, and therefore that signal comes down, and therefore if that signal comes down, then this one here has a more predominant effect, and this one goes up, and that one goes up. So this whole thing starts reaching an equilibrium. So that's how that seesaw phase inverter works. It is completely different in terms of values here. You've got 2.7 meg, 3.3, and a 10 meg resistor. So I'm not quite sure how they applied it here, but that's got to do with the different tubes anyway. Anyway, I want to carry on with the other one we want to look at, and to do that, I have deleted most of the signal path. I've gone one step further, and I've actually flipped around the mono and stereo switches. Like that one there was closed, now it's open. That one, where is it? There's the other one down here. That one there was down, now it's up. So we're going to carry on with the same signals, the blue and the red. And what we have at the moment is we've seen that our red signal comes in here, goes to there, but there's a small part of it, the low frequencies, that bleeds in to here, which then goes and meets up and joins the blue signal. And the blue signal comes here, goes up to there, and there's a bit of the blue signal that goes through there, the low frequencies, and meets up with the red signal that then goes up there. So we're going to keep following the signals, do it a little bit faster than before, because we've seen basically how the whole thing works. So this is the situation. We are here with a red signal. We go up there, we go there. We've seen that the path down is to the record. So we go up here and we get to there. And if we go to here, what we have is what we've done before, exactly the same. There's our bass control, there's our treble control, and let's just go straight to the pot. So we've got our signal now coming out of the pot, and this one is just going to there, straight into that tube. And it's doing basically all the tone corrections and all that stuff that I mentioned before on these circuits over here. Nothing new. And this circuit with this shorted, because we've neither activated medium wave or long wave, is now identical to this one down here. So down here, what we've got is now the blue signal. And the blue signal comes here, goes up there, meets the bass control. Same story, goes through there, meets the, the treble control over here. Comes through there, and it goes to the pot. And of course, it then goes through there, and it's into that triode. The only difference now is that this signal has actually allowed, or this switch over here, has allowed the blue signal to move in or move up independently of the red one. And we've got the same situation now, where this red signal with including the bass signal, or the bass frequencies of the blue signal, goes into this triode, into the grid. And this blue signal, which includes the bass signals of the bass frequencies of the red signal, goes into this triode. Now what happens here? What we have over here is that the amplified version of the blue signal goes up here, goes to there. Now let's just stop over here. We've stopped at this capacitor, and let's check if we've got supply. The B plus comes from here, up there, up there. There's our pickup input selected, so there's a 330K anode resistor to B plus. The same signal goes up there, 330K anode resistor to that one as well. So far, so good. Now, what happens to this signal here? Well, this one goes straight through this capacitor now, because this mono and stereo switch has actually been activated. It goes in here, goes in there, and now this is driving that power tube. So that's the difference. This guy is driving that power tube. Okay. And what about the top one? What about the top one? Top one comes out here. Let me just change the color on this. Top one comes out here, goes in there, goes in there. Just notice this forces, it's actually forcing it to go through this inverter. I actually thought that it would go straight from here somehow through a capacitor to there. But let me see, where are we? No, we're here. That would have gone. No, it's doing the same thing. It's coming back through here, up there, up there, up there, and then into there. So basically, yeah, it's inverting it. That's right, it has to invert it. Of course it has to invert it. It still has to invert it. Okay, the only difference now, this signal is exactly the same. It follows exactly the same path as it did before, through that Seesaw phase inverter to drive that tube. And the difference is now that this signal, or rather this tube, is not driven from here through here to there from the same signal. It's actually driven by this triode, but it's the same signal. These two are exactly the same phase signals, so that one needed to be inverted. Yep, that makes sense. Okay, so we can see that the pathways have been changed in terms of how they go through. However, you still get this phase inverter coming to play, and it has to. That makes sense, because you want push-pull on the bass frequencies. Otherwise you wouldn't get it. You'd get that working all right, but the phases would be reversed. Yeah, that makes sense. Okay, so that one goes through there, inverts, feeds that one. That one goes straight through that capacitor, and then meets another capacitor, and that gets fed there. Now I'm just checking something. There is a slight... yeah, this is interesting, because the actual capacitance between here and there, if it was here, if the signal's coming in here, it would get 10 nanofarads, but it's also going through a 33 nanofarad. So the actual capacitance between that point and that point is, you have to work those two in series, it's probably something like 6 nanofarads. And here it's slightly different. So there would be a phase effect. There would be a phase effect as in more than just the 180 degrees. Yeah. Okay. That's right. So I'm not surprised this thing is actually showing phase differences. Again, there may be something I'm not seeing here. I think this is correct. But what we get here really is the same situation with the feedback coming in. Now the feedback here is only affecting the one channel. This feedback from here goes to there, goes to there. That's the other difference. Yes, okay. There's the other difference. The feedback path that we saw earlier came here and met that cathode. But because the mono and, if you follow that path, there, the mono switch was closed, it went straight there, and it basically paralleled them. These two resistors were parallel to ground. This was basically a short cathode to cathode. Okay, that's fine. But now they've made it different. Now this path is open and you've got a 500 ohm resistor, or potentiometer really, which is bleeding some of the signal to ground. So you can at one point take this pot and the pickup is selected, so that's closed, and the mono stereo selected, so that's closed and that's ground. So if ground is here and it meets that wiper, what happens if you take this wiper and you feed it and you connect it to that point? In other words, in the extreme case of the wipers turned fully clockwise, okay? That means that point is ground. If that point is ground, that point is ground. If that is ground, it means our cathode is at ground. And if our cathode is at ground, this signal is forced to drop. You'll still get some, because it's a very big resistor here. You'd get grid leak biasing, but this would affect, this would affect the signal, the amount of signal coming out of one channel versus the other channel. And if you move it the other way, if you move this counterclockwise, then that point is connected to ground, and that point is connected to ground. So again, this triode is affected in that case. If you have this thing at ground and that thing at ground, that becomes 0 volt bias. I would think this would actually pass a hell of a lot of current, because you need a negative voltage to control the flow of current here. Again, there's something I'm not understanding here. I'm sure it might have something to do with the way the feedback works. But anyway, this is how that balance control works. It works by changing how the, or it actually changes the cathode voltage, the cathode resistance to ground. In effect, it's changing this resistor here as opposed to that one. I'm just not sure that you want that thing to be at 0 volts. Again, I invite you to help me here. If you can figure this out, if I'm missing something here, please feel free to comment. I always find those very enlightening, and I appreciate it. Anyway, where are we? Well, what we've got is an audio circuit that's showing some signs of strain, or some strange phase differences between left and right channel. I'm still not 100% convinced that it's only got to do with this inversion. There may be something else wrong over here. All it takes is for one of these lines to be different. In other words, one of these lines, if that there is different to the one that you'd see down here. No, that's not the case. That's not the case. Because in mono, that's not being used at all. So that's not the case. So whatever's happening, I'll probably, next time I get this thing on the bench, I'm going to check the signals in different spots. In other words, we are getting at this speaker and that speaker, we're getting different signals. They're not exact. They're not exactly the same. They should be practically the same. Now, it could be something over here. It could be something to do with the feedback path. So what I need to do is I need to test it there and there. Now, if those two are the same, if that is the same, it can only be here, because when we have this in mono, that thing is doing absolutely nothing. The signal is coming from here. So we have one common signal here that's going that way and down to this side. It's got to be here. It's got to be the effect of this tube and these this inversion and these components over here. If it's the same here, then it could be the fact that these tubes aren't exactly the same. But my guess is that it's got to do with the fact that you're putting in an inversion here with a triode that's from a completely different tube to this one. And that's creating that funny imbalance between the two. I think that sort of explains how this thing works. At least I think I've understood it. There's still a few little doubts, but I'm sure that it'll come to me. Hope you've enjoyed that. And if you have, please click like, share, subscribe, click the bell icon and all that jazz. And if you want to support the channel directly, you can do so on Patreon. I want to thank all my patrons. It's really great to get your support. Hope you all keep enjoying the videos. And I'll see you back soon with the next video on the restoration of this Grundig 4006 stereo. Thanks for watching. Bye for now. Stay safe.